Hello everyone, welcome to this video where we are going to explore what we call a standard form. Okay, standard form is a way that we actually write for very large numbers or very small numbers. Okay, so that we do not need to write so many digits, and it is written in this form: a times 10 to the power of some number. Okay, and this one I probably use a pink, purple. Alright, and this number for a, very important, the number for a is usually between 1 and 10. Okay, it can be equal to 1, but it cannot be equal to 10, meaning it can be equal to 9.9999999999999. Alright, and n is an integer. Okay, n is an integer, meaning it cannot be a fraction, nor it can be a decimal. Okay, and with that in mind, I'm going to relate this to an example here, where I have 1,350,000. I am going to rewrite it as 1.35 times 10 to the power of 6, and that will give me 1,350,000. Also, for a very small number like 0.0000345, I could also actually rewrite it as 3.45 times 10 to the power of -5. So this is another way of writing numbers, either very large or very small. Okay? And in most calculator, standard form is used with this button EXP, meaning 2 EXP 5. When you key into your calculator, it simply means 2 times 10 to the power of 5. So this 2 is representing the A, and this 5 is representing the N. And this EXP is representing times 10. Okay? Let's move on to the next part of this video. Since we now have some understanding of standard form and how it is written by. Hello everyone, for this part of this question, we are required to express the following in standard form. So for this particular question, let's zoom in on part A, where we are given 0.001010. So how do we actually write it in standard form? So for A, 0.001010 is equals to some number multiplied by 10 to the power of some number. And let's see what number it could be. For A, I could actually use 101 and write it as 1.01 and 3 times -3. Alright, And this will be the standard form for part A. Okay, and for part B, let's move on. For part B, we are given the following: 0.21 times 10 to the power of 4. We could write the 0.21 as such. I will write it as now that I know that I must have this. This is a small number, so I will write 0.21 as 2.1 multiplied by 10 to the power of -1. This is for my 0.21. Not forgetting, there is still my 10 to the power of 4 here. Okay, then I still have my 2.1, but for this, I could actually times 10 to the power of, the base is the same, 10. I could actually have my -1 plus 4 using my law of indices, and therefore my final answer will be 2.1 times 10 to the power of 3. Alright, and let's move on to part C, where we have 0.0052 times 10 to the power of -3. Again, you will see Mr. Tan trying to count the number of times for the decimal. And for the number A, I will write it as 5.2. And this one times 10 to the power of -3, because it is a very small number. And this is for my 0.0052. Not forgetting my times 10 to the power of -3 that is still here. I must still continue to do that. And finally, I still have my 5.2. But now I could actually apply my law of indices for this part here, where the base is same. So it will be -3 plus my -3. And finally, I will get my final answer as 5.2 times 10 to the power of, this one will give me -6. Let's move on to part D, where we will have 3259.2 times 10 to the power of 6. Now we are looking at big numbers. So let's see. 1, 2, and 3. 3 times to the left. You will see Mr. Tan rewrite this as 3.2592 multiplied by 10 to the power of 3. Okay, so this number 3259.2, I have rewrite it in standard form. And not forgetting my times 10 to the power of 6. I still need to write that down. And finally, continue. This is already in the first part of the standard form. My job now is to simplify the same base 10. Okay, and that will be 10 to the power of 3 plus 6. So that finally this will be the answer for part D. Multiply by 10 to the power of 9. And for part E, where we would have 500 times 10 to the power of negative 3. If there's no decimal point, where's the decimal point? Yeah, here. So 1, 2. So I could rewrite 500 as 5.0 or 5 times 10 to the power of 2. So this is the 500. And not forgetting my 10 to the power of negative 3. And finally, 5 times 10. Have to simplify the 10. Base 10, same. And when I multiply, so it will be 2 plus negative 3. Final answer, 5 times 10 to the power of negative 1. Standard form. And the last part, this will give me, alright, so for this question, 1 over 20,000 is actually equal to 0.00005. And therefore, you will see Mr. Tan, 2, 3, 4, 5. And therefore, Mr. Tan will rewrite this as 5 times 10 to the power of positive or negative 5? Negative 5, because this is a very, very small number. Alright. With that, we have come to the end of this example. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are required to evaluate the following without using a calculator. So without further ado, let's zoom in on part A. Okay, all these are given in standard form. So the very first question, you will see Mr. Tan rearranging as such 8.1 times 7 times 10 to the power of negative 23 times 10 to the power of negative 22. And from here, this will give me a value of 56.7. As for here, I saw that they are the same base, so I'm going to multiply by 10 to the power of negative 23 plus my negative 22. So the next line will then see me writing this as 56.7 times 10 to the power of negative 45. Okay, so this power will give me negative 45. Next, is this the standard form? Nope. because I could continue to rewrite 56.7 as 5.67 times 10 to the power of, I move this one time, 1. And therefore, you will see Mr. Tan here writing this down. So this part here is in standard form already. And finally, that's the final answer. 5.67 times 10 to the power of 1 plus negative 45. Because the base is the same, I'm going to add the power together. This will give me a final answer of 5.67 times 10 to the power of, what is this? Negative 44. Okay, let's move on to part B. Okay, we are going to divide 1.5 times 10 to the power of negative 7 divided by 7.5 times 10 to the power of 3. So for this, right, we are going to do this. 1.5 divided by 7.5. This will give me 0.2. For this, because we are going to divide using what we have learnt from indices, I am going to just minus the power, minus 3. So this will give me 0.2 times 10 to the power of negative 10. And for 0.2, it is not yet in standard form. I do have to rewrite it as standard form. So I'm going to write it as 2 times 10 to the power of negative 1. Alright. This is for 0.2. Not forgetting my 10 to the power of negative 10. So final answer, 2 times 10 to the power of negative 1 plus negative 10. To take note, we are going to plus the power together when the base is the same. And finally, you will see this as the final answer, 2 times 10 to the power of negative 11. Okay, I'm going to use this color. Okay, negative 11. Let's move on to part C. Alright, we have a plus. Now things are a little bit different, because when we are dealing with plus, we do need to make sure that we can find a common factor. What do I mean by that? So you will see Mr. Tan rewriting this 10 to the power of 6 as such. It will be 4.8 times 10 to the power of 1 and 10 to the power of 5. This is still the same. Why do Mr. Tan break the 10 power 6 into 10 power 1 and 10 power 5? Because Mr. Tan would like to make sure that there is a common factor, 10 to the power of 5. Okay? And then we could simply add this up. So this will give me a value of 4.8 times 10 power 1. I need to plus 5.9. The common factor is 10 power 5. I repeat, this is the common factor which I've taken out. So finally, this will give me a value of 53.9 times 10 power 5. But this is not yet the standard form. So I still have to rewrite 53.9 as so one time. So it will be 5.39 times 10 to the power of 1. Still got my 10 to the power of 5 down there. And so finally, you will get the final answer as 5.39 times 10 to the power of 1 plus 5 will be 6. And that will be the standard form for part C. And let's move on to part D. Minus is same as plus, meaning I do need to find a common factor. So in this case, right, I would express 10 to the power of negative 9 as 10 to the power of negative 8. So how do I make sure that? So you will see Mr. Tan writing this down. So the 1.7 still there, but I will write this as 10 to the power of negative 1 and 10 to the power of negative 8, because negative 1 plus negative 8 will give me negative 9. And there's a reason for this, because then I would be able to take out the common factor out. This is the common factor, right? And I'm left with 6.7 minus 1.7 times 10 to the power of negative 1, close bracket. And this will actually give me a value of 6.53. And this is the standard form. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are required to solve this, and there is a standard form. So for the very first part, right, part A, it's quite straightforward. They want us to represent the population in standard form, meaning 3,880,000 in standard form. So this will be equal to 1, 2, 3, 4, 5, 6. 6 times 3.88 times 10 to the power of 6. Done. Part B. The total length of Singapore is 640 kilometers square approximately. Calculate the average number of people per square meter. Oh, very important. They say average number of people per square meter. So this means that they would want us to express average people. People, what is the number of the people? People is here. 3.88 88 times 10 to the power of 6 people. Per means divide. Land area, they give us at 640 kilometer square. So the question itself already tells us the working. Alright? And after that, this will give me a value of 6,062.5. But they do want us to give my answer correct to 2 decimal place. So meaning I will then have to rewrite my answer as such to 2 decimal place. Alright, we have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are required to express the answers in standard form, okay, after we calculate them. Alright, and we are given A and B as standard form. So for part A, let's zoom in. Alright, so for part A, I'll write it here. AB simply means 2 times 10 power 3 multiplied by 4 times 10 negative 5, and so 2 times 4 is 8. 10 power 3, 10 power negative 5. What do I do to the power? Very good, I add them out, and that will give me negative 2. And that is indeed the standard form. So for part B, now I'm going to have A divided by B, so meaning 2 times 10 power 3 divided by 4 times 10 power negative 5. 2 divided by 4 will give me 0.5 times my 10. What do I do to the power when I divide? Yep, I minus. So 3 minus negative 5. This will give me 0.5 times 10 power 8. And 0.5, I'm going to rewrite 0.5 as 5 times 10 power negative 1, because the decimal place go back by 1 time. Not forgetting my 10 power 8. Final answer, 5 times 10 to the power of 7, because negative 1 plus 8, same base, they will give me 7. Last part of the question, we will have A plus 1 over B, meaning 2 times 10 power 3. I'm going to add 1 over 4 times 10 power negative 5. So this one will be equal to, so I'm going to do this. 2 times 10 to the power of 3 is 2000. And so this is equals to this, and for the other one is actually equals to 25,000. So this is equals to this, and when I add them up, it will give me 27,000, and I'm going to write them as standard form. 2.7 times 10 to the power of 4. With that, we have come to the end of this example. Let's move on to the next example. Hello everyone, welcome to this part of the video where we are looking at very big or very small number with all the names given to this set of powers, and there are special names. So for example, 10 to the power of negative 12, we actually call it a pico. The moment you see a pico, you know this represents 10 to the power of negative 12, and decimal would then be 0. Here we'll have 11, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1. So for nano, then you will know 0.0, 1, 2, 3, 4, 5, 6, 7, 8, 1. For micro, 10 to the power of 6. 1, 2, 3, 4, 5. And for milli, 0.001. 10 to the power of 0 is 1. 10 to the power of 3, 1000. 3 zeros. 10 to the power of 6 will have 60. Giga is 90. Behind, which is a billion. And for trillion is 10 to the power of 12. So there will be 12 zeros. Alright, so let us now look at questions that make use of all these prefix or the name. Alright. So for this particular question, then we are given that the storage capacity is in gigabyte. The moment you see gigabyte, you must remember that giga is 10 to the power of 9. So for part A, right, you will then see the size. They give us this. So it is simply 32.5 gigabyte. 32.5 times 10 power 9. Giga is 10 power 9. Give your answer in standard form. So you will see Mr. Tan writing 32.5 as 3.25 times 10 power 1. Because I moved by 1. So the blue color with the blue color. Still have my times 10 to the power of 9. And finally, 3.25 times 10 power 10. Because when I plus bases with the same base, the power, I add them up. So that's for part A. Part B, the size of each document is 65 kilobyte. So 65 KB is simply 65. Kilo is 10 to the power of 3. Okay. Kilo is 10 to the power of 3. How many documents then can we find? So the number of documents then is simply equals to division, right? I got so much space. 32.5 gigabyte. I also have 65 times 10 power 3. And therefore final answer you will get is equals to 500,000. And this translates 5 times 10 to the power of 5. We have come to the end of this example. So let's move on to the last example for this subtopic.